This is Sharma solution, class 12, chapter 19, exercise is 19.26. We are taking indefinite integrals. Now this question, erase x 1 minus x square by 1 plus x square to the power square. Now this exercise needs a relationship to comprehend with the question. That means that we need to have erase x and fx plus f dash x. If this is relating to our question, we can directly write erase x fx plus c. So we need an fx from here, but right now this is just one function. We need fx plus f dash x, that is a function along with the differentiation of that function. So let's start from here. So I'm trying to simplify it and trying to divide these function into two so that we get a function and the differentiation. So 1 minus x square, I'm opening a minus b whole square, so a square plus b square minus 2ab. And in the denominator we have 1 plus x square to the power square. So this is 1 plus x square to the power square. And let's part it, that is 1 plus x square divided by 1 plus x square whole square, and here negative 2x divided by 1 plus x square whole square. Now this gets cancelled. You have 1 by 1 plus x square as the first function, and second function comes out to be 2x divided by 1 plus x square whole square. Now if you take 1 by 1 plus x square as fx, then you know already the differentiation very well. So negative 2x divided by 1 plus x square whole square is the differentiation, that is f dash x. So when you differentiate it, let me do the differentiation in front of you so that you understand that the second part which we divided is actually the differentiation one. So 1 plus x square to the power minus 1 when we take it upstairs, and now we are differentiating. So it will be negative 1, 1 plus x square to the power negative 1 minus negative 1, that is negative 2. And this comes out to be negative 1 because 1 plus x square to the minus 2 when we bring it in the denominator. One more thing, 1 plus x square has to be differentiated again, that is 2x. So negative 2x divided by 1 plus x square whole square. Now this has come as the differentiation of the first function, which is 1 by 1 plus x square. This is fx, this is f dash x. Now we have fx and f dash x, and it has a direct relationship or the result, which is erase x fx. What is fx here? 1 by 1 plus x square. So erase x by 1 plus x square plus c is the final result. But if you are following me and you have seen that we need more explanation, if the question is gaining more marks or it demands more explanation, then we have to actually solve it in another way. So this step has to be done. All this step has to be done. Just assume that we have separated these two, and this is erase x and then the integration sign. So this erase x 1 by 1 plus x square is your starting point. So we'll take erase x fx, which is erase x 1 plus x square, as some t. When we differentiate this, we are differentiating now. So since we have already differentiated this 1 by 1 plus x square, so we can directly write it's negative 2x divided by 1 plus x square whole square. Then we have plus 1 by 1 plus x square, and erase x will be erase x only. And this is on the right, we have dt by dx. Now I'm just rearranging, taking erase x outside, and I'm just swapping these two terms. So 1 plus x square comes first, and followed by negative 2x divided by 1 plus x square to the power square. And this is equal to dt, dx I'm bringing on the left hand side. And now next step will be integration. So let's integrate now. So when we integrate, you don't have to worry about the integration of the left hand side, because the integration is actually the question only. This is only question, you don't have to integrate. So this is I only. We resolved it, and that is how this has come. So you can directly write erase x 1 minus x square by 1 plus x square whole square also. So it's I only. So I will be equal to integration of dt will be t plus c. And what was t we assumed initially? It's erase x by 1 plus x square and plus constant of integration. This is I. So how we are going to solve it? This is the step-by-step solution. This is a step-by-step process which you have to follow. And next one is erase x by 1 plus x by 2 plus x square. So we again want fx and f dash x. So we have 1 plus x by 2 plus x whole square. And since x plus 2 is already there, so we'll make the numerator as 2 plus x. For that we have to add a 2 and subtract a 2. So just add a 2, subtract a 2, and separate this x plus 2 and the term which is coming afterwards. X plus 2, 1 minus 2 is negative 1, and denominator remains the same. So you can just write that 2 plus x is x plus 2 whole square. This is just to add the complexity. That is why it is written 2 plus x, not x plus 2. So when we separate them out, x plus 2 can be cancelled. It will become 1 by x plus 2 minus 1 by x plus 2 whole square. So 1 by x plus 2, if you take it as fx, 1 by x plus 2 whole square will be differentiation of that function. Now if you just add erase x and add an integration sign, This is nothing but our integration only, and it is following the formula that is e raised x fx plus f dash x. So it's simply e raised x fx plus c. So e raised x, what is fx? In this case 1 by x plus 2 plus constant of integration. Okay. Now if this question needs more explanation, that is this question carries more marks, then you need to follow another way. This step you have to do, all this until this point you have to integrate, means simplification has to be done. And from here, just take e raised x fx. What is fx here? In this case, we'll take 1 by x plus 2 as fx. So e raised fx equals to t has to be taken. Now e raised x fx, that is e raised x by x plus 2 equals to t. Now we differentiate both the sides. Differentiation we have already done of 1 by x plus 2, that has come to be negative 1 by x plus 2 whole square. So we don't have to do it again. Just 1 by x plus 2 e raised x. Now negative will come because we know that 1 by x plus 2 differentiation will give you negative 1 by x plus 2 whole square. So I'm writing it now, and e raised x remains same. On the right we are differentiating, so this will be dt by dx. We are differentiated now. This is the step after differentiation. Now we'll just rearrange this. We are taking e raised x outside, 1 by x plus 2 will remain, and negative 1 by x plus 2 whole square will remain. And this is dt by dx. Dx goes on the left. So this is the function, you can say, or the equality where we have to integrate now. So when we integrate, you don't have to worry about integrating because this is I only. This 1 by x plus 2, negative 1 by x plus 2 whole square has come from the original equation only. So I equals to t plus c. Alright. So this is equal to e raised x by x plus 2 plus constant of integration, because t was assumed to be e raised fx, which is e raised x by 2, e raised x by x plus 2. So this is the process 1, this is process 2, whichever you want, you can just solve it depending upon the explanation and the marks. Alright. Now the logic I have already told you, and this is how you're going to write. These are the steps you need to follow so that you actually solve this question. And these questions are very important because this exercise, most of the questions I've seen that they have come in the exam maybe a few years earlier, or maybe few years after it will come. So you need to get prepared. Now we have under root 1 minus sin x divided by 1 plus cos x, and we have e raised minus x by 2. So integration of e raised x fx plus f dash x. If we can get hold of this relationship and it can relate to the original question, we can directly write e raised x fx plus c. So the whole idea is to find out fx here. So we need to do something here, and right now 1 plus cos x is already in the denominator. You know already that it can be written as 2 cos square x by 2. How about the numerator? We need to get rid of the root first. So for 1 we can write a sin square plus cos square. So let me write sin square plus cos square, and since 1 plus cos x is going to be 2 cos square x by 2, we'll write sin x by 2 cos x by 2 whole square. And this sin x, which is coming afterward, can be written as 2 sin x by 2 cos x by 2. So let me write it sin square x by 2 plus cos square x by 2, which will eventually become 1. And sin x is simply 2 sin x by 2 cos x by 2, that you already know. And this is inside our under root. So whole idea is to get rid of the under root. This denominator will be 1 plus cos x. This can be written as 2 cos square x by 2. This is also a straightforward formula. So a square plus b square minus 2ab is a minus b whole square. This is actually a formulation of a minus b whole square only. A is sin x by 2, b is cos x by 2. You can just square it, put a under root, and denominator remains as same, 2 cos square x by 2. And this root gets cancelled with the square. So you can just write sin x by 2 minus cos x by 2 divided by 2 cos square x by 2. So this 2 cos square x by 2 I am separating now, because sin x by 2 divided by 2 cos square x by 2 will be one term, and cos x by 2 divided by 2 cos square x by 2 will be another term. So sin by cos square. Okay, there is an issue here. Not that issue, but I'm just saying that you have to think more over it. Cos x by 2 gets cancelled. You will just get 1 by 2 cos x by 2. Cos x by 2 goes up. It will become sec x by 2. So 1 by 2 sec x by 2 goes up. So 1 by 2 sec x by 2 is okay. 1 by 2 remains like this on the first term. Now we have to separate these two terms and try to find out in a way which we can be equating it or relating it with this sec x by 2, which is the second term. So sin by cos can be written as tan x by 2, and 1 by cos can be written as sec x by 2. Now there is a relationship between differentiation of sec x by 2 and sec x by 2 tan x by 2, because sec x by 2 when differentiated gives you sec x by 2 tan x by 2. Alright, so we can take this half out if you want. So integration actually becomes, after this resolution, you can say integration of sec x by 2 tan x by 2 minus sec x by 2 and there is a dx already, right? We are actually integrating, but there is one more thing, which is e raised minus x by 2. Now here we get stuck, because initially in the beginning of the question I told you e raised x fx plus f dash x. So if you forget about fx plus f dash x, e raised x will actually give you this solution, but we are dealing with e raised minus x by 2, and that is not the case. E raised x is not equal to e raised negative x by 2. So for that we have to do something different, something else. So let's deal with it now. I was actually what? It was half integration of sec x by 2 and 10x by 2 minus sec x by 2. And then it is, you can just multiply also if you want. That is e raised minus x by 2, e raised minus x by 2 can be multiplied. And this is a dx. So this is the original question actually. We just resolved it and put it like this. We haven't integrated as of now. And when you take this sec x by 2 e raised minus x by 2, that is if you take this e raised negative x by 2 sec x by 2, and when you differentiate this, if e raised minus x by 2 sec x by 2 10x by 2 comes, then you are in a good page. So let's differentiate this. I am assuming t as e raised minus x by 2 sec x by 2. I am differentiating now. So when you differentiate sec x by 2, it will be sec x by 2 10x by 2 with a half. I am not writing the sign now because I am just writing sec x by 2. I am following the product rule. So e raised sec x by 2 will come like that. E raised minus x by 2 has to be differentiated. It will come as e raised minus x by 2, and then we have to differentiate negative x by 2, which is coming as negative half. So just write minus and half here. Okay. You are aware that this is good. Now we have just taken t equals to e raised minus x by 2 sec x by 2 and differentiated it. Now I am taking this dx on the right hand side. So you can take half outside or you can take it inside also. It's up to you, because I have written the first lines, you see. I've written as half as outside. That's why I'm putting it like this. So e raised minus x by 2 you can take outside. Sec x by 2 10x by 2 remains here. And this sec x by 2 comes here. And dx I'm bringing on the upstairs of the right hand side. Now when you put this integration sign on both the sides, you will see that this whole is nothing but I. Now just try equating these two equations. They are exactly same. So you can just write I. Integration of dt will be t plus c. And if you remember, t was taken as e raised minus x by 2 sec x by 2. So you can write e raised minus x by 2 sec x by 2. And this is going to be your final answer. So we haven't applied the formula, what we have learned in this exercise. We did that higher explanation way to solve and present it to you. So this is the way you're going to solve it. And these steps are very important. This is a very good question because it needs a lot of trigonometry along with the integration capability. Now this e raised x log x plus 1 by x, and this is very straightforward question because log x, if you take as fx, f dash x is directly 1 by x, because differentiation of log x is 1 by x. So you can directly apply the formula here. E raised x fx plus f dash x, it is matching. So e raised x fx plus c will be the answer. And fx in this case is log x, which is quite evident when you see this. So e raised x log x plus constant of integration. But if this question needs more explanation, then we'll follow the rules which we have been doing up till now. So e raised x fx, what is fx here? Log x. So we'll take e raised x log x as t. So just take e raised x log x as t and differentiate both the sides now. This is dt by dx, e raised x log x, let's differentiate it. So e raised x by x, log x remains like that, e raised x. Now you can take e raised x common here. You'll get log x plus 1 by x. I'm just rearranging it so that it matches the question. So log x I'm bringing first, 1 by x I'm writing like that. And this is dt, dx I'm bringing on the left upstairs and integrating both the sides. When you integrate both the sides, first we differentiated, now we integrated. But don't integrate because this whole left hand side is actually the question. So you can just write I. On the right hand side, dt integration will be t plus c. T was taken as e raised x log x because it was e raised x fx plus c. Just change this fx as log x. So just write I equals to e raised x log x plus constant of integration, and that's your final result. Okay, this question needs this kind of solution, and you can follow these steps if you're doing it by yourself. Okay, this question will be taken later. Till then, thank you so much and have a good one.